In this presentation, we're going to do a quick version, the need-to-know version for transformations. A transformation is a change, and in this course, we'll graph complicated curves by referring back to the parent function and then applying transformations, i.e. changes, to them. The process is the same regardless of the parent function relevant to a given situation. When we write f of x, the input of the function is f is x. So for example, when we write y equals 6f of 3a plus 5 minus 1, the input of the function f is 3a plus 5. In casual terms, the input of the function in the brackets to the right, the input is the expression in the brackets to the right of the letter representing the function. Ultimately, as we seek to graph the function y equals af of kx minus d plus c, we'll remember that the function is f and the input is k bracket x minus d. Now here's a mapping formula. If xy is on the curve y equals f of x, then x over k plus d, ay plus c, is on the curve y equals af of k x minus d plus c. That leads us to a mapping formula which is shown below in red. Make sure that you factor k in the input of the function if it's not already done. What does the value of a do? Well, if a is greater than 1, then there's a vertical stretch by a factor of a. If a is in between 0 and 1, then there's a vertical compression by a factor of a. If a equals 1, then there's no transformation. And if a is negative, then there is a reflection in the x-axis. In addition, there might also be a vertical stretch or vertical compression. You can tell that by looking at the magnitude of a and then determining whether the magnitude of a is greater than 1 or less than 1. The value of k. If k is greater than 1, there's a horizontal compression by a factor of 1 over k. If k is in between 0 and 1, then there's a horizontal stretch by a factor of 1 over k. If k equals 1, there's no transformation. If k is negative, there's a reflection in the y-axis. And if that's the case, then we also look at the magnitude of k to determine if there's a horizontal stretch or horizontal compression in addition to the reflection in the y-axis. And if the magnitude of k is greater than 1, then there's a horizontal compression by a factor of the magnitude of 1 over k. And if k is negative and the magnitude of k is less than 1, then there's also going to be a horizontal stretch by a factor of the magnitude of 1 over k. The value of d. Remember that to determine the value of d, you want to make sure k is factored out in the input of the function, and then make sure you change the sign in the bracket. If d is greater than 0, there's a translation to the right, and if d is less than 0, there's a translation to the left. Then the value of c. If c is greater than 0, there's a translation up, and if c is less than 0, there's a translation down. The default settings of a and k are 1. So in other words, if a or k are not apparent, then their assigned value is 1. And why is that? Well, let's look at footnote 1. It's because the operations associated with a and k are multiplying and dividing. The identity in these situations, in other words, the number that you can multiply or divide by without changing the value, is 1. The default settings of c and d, on the other hand, are 0. Why is that? Well, let's look at footnote 2. It's because the operations associated with c and d are adding and subtracting. The identity in those situations, in other words, the number that you can add or subtract without changing the value, is 0. And that is the end of the expedited version, the need-to-know version of transformations.